make it.
That's a lot of
Nope.
3s and 2s. So between 4 and 5, everyone choose one of those.
Oh,
What is wrong with y'all?
why would y'all do that?
That was so easy.
How is easy?
There's
I didn't even do it.
mixture.
I want to do 4.
Let's
do the first
10, 4, 5, 6, 7. Okay, 5, 1.
5?
Was
It's
I said 2, 3. For number 2 and 3, those will be done in Desmos. Okay, so if I were to put this into Desmos, the whole thing, I would get x equals 4. So all of your equations to include number 4 should be put in Desmos because it'll give it to you. Number 3, if I put in the order pairs, and I counted this slope, so down 6 to the right 12, that would give me a negative 1/2. And sorry, we're trying to find the equation of the line. So type in your y equals mx plus b. Add in all your sliders. Change your m to negative 1/2. And then move your b until it goes through those 2 points. So your equation would be y equals negative 1/2 x plus 2. Like this. All of your slope writing equations, parallel perpendicular lines, all of that can be done in Desmos, so make sure you are utilizing Desmos. And then the last one, I'll write those numbers up here. Make sure you're use Desmos. He incorrectly solved this inequality, and we have to find between what 2 steps. So from step 1 to step 2, he moved 1 over, and that's fine. That's not what we would normally do, but we could do that. Step 2 to step 3, he distributed, and this should be negative 4x and positive 28, so that's good. Step 3 to step 4, he subtracted 28 to get negative 32, so that's good. Step 4 to step 5, when he divided on both sides, this should be facing the other way. So between step 4 and step 5. If you would put this into Desmos, the original, you would see that this is a vertical line shaded to the right, and that would tell you it's not less than also. Make sure your names are on your answer sheet. Go ahead and pass those up. Okay, we did example 1 yesterday. I will say example 2 will be similar to that, but let's try example 3. Does this one have a GCF? So then this is our true to life a doesn't equal 1 trinomial, where we multiply 2 and negative 5 and find the factors of 10 that would add or subtract to be 3. And because it's negative, one of them is going to be negative. 2 and 5. Which one will be negative? Negative 2. And that's what that says. And then rewrite this into 4 terms. Does not matter the placement, the order in which you put your negative 2 and 5. And then split that down the middle. Find the GCF of the first two, which would be what? 2x. What would be left? Minus 1. What can we divide out of the last two? 5. Positive 5. Leaving x minus 1. Rewrite those into your final factors, 2x plus 5 and x minus 1. And then if we set both factors equal to 0, this one we would know is what? 1. But this one we need to solve. What would that other 0 or solution be? What would this solution be? Negative 2.5 or negative 5 halves. Either or, you can write it either way. If it gives you a decimal, not nice decimal, leave it as a fraction, but this one doesn't matter. So a lot of your a equals 1 problems will give you fractions. Sometimes they'll both be fractions, sometimes just one, it depends. What questions do we have on that? Any of that?
So you can solve that in like
We can't use a equals 1 because it doesn't. We can't use GCF because it doesn't have 1. We can't use difference of squares because it's not a binomial. Look at some of your other problems. I would say probably not the GCF ones, but example 4, example 3, example 4. Any of those we want to see you go over. This one or example. We'll do this one and then we'll go on. So, does this one have a GCF? No. So then, same process, multiply 5 and 3. And we're looking for two numbers that multiply to be 15 but add to be negative 8. Add or subtract to be negative 8. 5 and 3. How would we make it negative 8? Negative 5 and negative 3. So then rewrite that into 4 terms. Split it down the middle. Find the GCF of both sides. What would that be of the left side?
5x.
5x. Leaving what? X minus 1. What would the GCF on the right be? Negative 3. Leaving x minus 1. And then when we set both of our factors, when we write both of our factors, and then set them both equal to 0, Go ahead and solve this one. What are two factors? 3 over 5 and 1. Go on to the next page. A lot of these other ones are similar until you get to the bottom. So these are where you have to solve it first before you do anything. Do we have any questions that we want to see in 11 through 14? 12. So in 12, I have to move the x term back over. I would say wherever your, bless you, x squared is positive or would make it positive, move it to that side. It doesn't have to be, it would just make your life easier. And then how would I factor this?
Okay, so you always have to move the one in the middle.
We have to move whatever if it's not equal to 0 over. Depending on what that is, it's not always the same. The x term, just x goes in there. Because of your standard form. Yes. Do not have a DCF, so multiply 8 and 3.
Okay.
It is a prime number, but it doesn't have a DCF. And it's not an 8 equals 1 trinomial. 6 and 4.
There's no chance. So you should always have a equals 1.
Not always. That's just one of the types. So negative 6 and negative 4 would subtract to be negative 10 and multiply to be positive 24. And then start to find your GCFs. 2x on the first, for the first two, leaving minus 3. And then what can we divide out of the last two? Positive or negative? Negative 1. I'm going to do this in this space because I ran out of space. So then when we set both equal to 0, you're going to end up with two fractions. Go ahead and solve those and find them. Other questions I kind of did, wrote in 11 space, so probably not 11, but questions on 13 or 14 before we move on? Yes. Go on to the next page. Go ahead and write this. Quadratic roots, remember that's another word for x-intercept solution. Zeros are the points at which the parabola intersects the x-axis, also called zero solutions, x-intercepts. Draw in these rough sketches. the algebraic methods that we were just doing can be done graphically, but if it asks you specifically to do it algebraically, you need to do it that way. But every time we factor and we end up with two solutions, that was your problem crossing your x-axis twice. It was rare that we found one solution, but if that happened, it just touched it once. And then we haven't factored and found no solution because that would just be prime, and you can't factor a no solution. You have to use the quadratic formula. / there are imaginary numbers at play. And that's an algebra 2 concept. So along with your other characteristics, your domain, range, vertex, axis, and symmetry, you'll also need to state the zeros or roots, solutions, x-intercepts, which we can do in the graph. You can do it by factoring. So these ones we're just going to do in the graph, in the calculator. When you're practicing, you could do this in Desmos, and I'll show that too. Does anyone still need this? In your calculator, go ahead and put in this in your y equals. And go into your table, second graph. A quick way to find your vertex is look for your y values that are repeating and find the middle of those. Where would that be? The 0 repeats, so that's not the middle. So find the middle of these. Where it stops repeating, where the y value stops repeating. -2 and -9, so that's going to be your vertex. Put that in the middle. And then fill out the rest. So I'll do x's first. You have -8, -5, and 0. And then it would just repeat. Then I'm going to graph those points. Remember that it's symmetric, so once you get half of it, you should be able to copy the other half. I'm going to highlight the x, y axes just so we see it a little bit clearer. What are our solutions here? Where does it cross the x-axis? -5 and 1. So you can see that from the table, you can see it from the graph. So you would write that in your curly brackets again. X equals -5 and 1. So that one I could say has two solutions. It crosses it twice. I'm going to skip down to number 3. If you had something where maybe the zeros weren't clear in your graph, if you wanted to also, if they were there and you could count them, that's fine. If not, go into second trace and find your zeros that way. But I'm going to go ahead and put in number 3. And then go into the table. Where is that middle? 1, -2. Go ahead and fill those out. We have -3, -6, -11. And then it would repeat. And then you could graph those points. If you want to draw the 11s, it would just be one off the graph. What are our solutions for this one? Do we have any? It doesn't cross the x-axis at all. We don't have any solutions. Go on to the very last page. So not only do you have to be able to find your solutions from a graph, but you also need to be able to write the equation using said solutions from the graph. So in this, start off with finding whatever your solutions are. X equals 2 and x equals -4. Then we're going to work backwards. Before we were factoring, getting factors at the end, solving that to be 0. Now I want to put this back in factor form. So if I had this in factor form, what would this look like? X something with 4. Would it be plus or minus? Plus. Because it's always going to be the opposite. If I were to set this equal to 0 and solve, I would get this solution. So then it'll be x minus 2. So then to get our equation, then going back even further, we're going to distribute this. So x times x would give us x squared, and then we have -2x plus 4x minus 8. Combine like terms. What's our final equation? X squared plus 2x minus 8. And if I put this in and this in, they should overlap, and I would be able to see those zeros also. Alright, let's try one more. I'll let you guys choose 2, 3, 4. So of those, 2, 3, or 4? Which one? 3, okay. So what are those zeros for 3?
I'm on the wrong one.
Negative 8 is one of them. Negative 3. How would I write those as factors? X plus 8, x plus 3. Let's distribute. So we have x squared plus 3 plus plus 5. And then combine like terms. What's our final equation? X squared plus 11 x plus 20. Right. So I said I was going to show this in Desmos also, so I'll do that really quickly. If individually you need me to show you in the calculator, again, I can do that. I'm about to make up something. So whatever your quadratic is, if you look on the x-axis, it'll tell you what those solutions are. If you wanted to find points from this, go into your gear wheel, change this to a table, and then you'll see your y-intercept, but you may have to add in some other points to find your vertex. Now, your vertex is given, so you could put in that and then go around. So maybe I want to know what this point is, and I can put in negative 3 and then go from there. Okay. You have a little bit of time to practice either in the notes. This does math, that's due Friday. The characteristics of exponential functions, that's also due Friday. Or JLabs, or past us math. So work on that for a little bit, and then I'll tell you when you can write it.